Welcome to the Deep Dive. Today, we're plunging into something pretty significant in the AI world. It's the recent release of these new open-weight reasoning models, GPT-OS 120B and GPT-OS 20B. And look, this isn't just, another small update. It feels more like a genuine shift in AI accessibility and, innovation. We're essentially going to sift through the official release info, kind of like digging through research notes, to pull out what really matters. Our goal today, unpack what makes these models a big deal, figure out who really benefits, and what it signals for the future of open source AI. So let's jump right in. GPT-OS 120B and GPT-OS 20B, what's the main story here?
Yeah, so the headline is basically this. You've got state-of-the-art open-weight language models. And the promise is strong performance, real-world performance, but at a remarkably low cost. Now, open weight, what that means here is the weights, the core of the model, are out under the Apache 2.0 license. And that's huge, right? For developers, for researchers, it gives them loads of flexibility to use, tweak, share, even commercially. And right away, they're highlighting some key things, beating similar-sized open models on reasoning, solid tool use capabilities, and maybe most importantly, they're optimized to run efficiently, even on consumer hardware.
Right, and that's the part that really grabs you, isn't it? Think about what becomes possible when AI this powerful isn't just locked away in, giant server farms, running it on your own gear, your own server, maybe even a high-end laptop. That really changes the game for innovators everywhere.
Okay, performance. You mentioned that, and this seems to be where things get, really compelling. Sometimes with open source, there's this expectation of maybe a slight performance hit, right? A trade-off. But the claim here is that these aren't just good for open source. They're actually competitive with some big proprietary names.
That's exactly it. The performance benchmarks they're citing are quite impressive. Let's take the big one first, GPT-OS 120B. They're saying it hits near parity with OpenAI's O4 Mini on core reasoning tasks. And get this, it does that running on a single 80 gigabit GPU. That's pretty efficient.
Wow. But there's more. It actually outperforms OpenAI's O3 Mini model. And it matches or even beats a 4 Mini on some really tough stuff, like competitive coding code forces benchmarks, also general problem solving like MMLU and HLE, and tool use measured by HealthBench. And here's a real kicker. It apparently surpasses proprietary models like OpenAI O1 and even GPT-4o on HealthBench. And it outperforms a 4 Mini on competition math, specifically AIME challenges from 2024 and 2025.
Okay, hold on. Outperforming GPT-4o on health benchmarks and O4 Mini on math. That's significant.
It is. And then you have the smaller one, GPT-OS 20B, smaller footprint, obviously, but it's still delivering results similar to OpenAI's O3 Mini on standard benchmarks. And this one can run on edge devices. Needs just 16 gigabytes of minute.
16 gigs. That's like consumer level.
Exactly. And performance-wise, it matches or beats O3 Mini on code forces, MLU, HLE, HealthBench. And like the bigger one, it even outperforms O3 Mini on competition math, AIME again, and on HealthBench too.
Right. So the takeaway for you listening, whether you're deep in development or just following AI trends, is that accessibility doesn't mean sacrificing power here. These models are genuinely pushing the performance boundaries for open-weight AI. It's not necessarily an either choice between open and performant anymore. Looks like you might be able to get both, which leads to the obvious question, how? How did they manage this? What's under the hood? What's the secret sauce?
Well, it really comes down to some pretty sophisticated engineering. Both are transformer models. That's standard now. But the key tech is mixture of experts. MOE. You can kind of think of MOE as having like specialist teams within the model. When the model gets a task or really a token of information, it doesn't fire up all its billions of parameters. Instead, it smartly routes the information to just a few relevant experts. This drastically cuts down the active parameters needed at any one time, makes inference way more efficient without crippling the capability.
Okay, so it's selective activation.
Exactly. To give you the numbers, the GPT-OS 120B has 117 billion parameters total. Huge number. But for any given token, it only activates about 5.1 billion. That's across 36 layers, with 128 total experts activating 4 per token. And the smaller GPT-OS 20B, 21 billion total parameters, but only activates around 3.6 billion per token. 24 layers, 32 experts total, again 4 active.
So MOE is a big part of the efficiency story. What else?
Yeah, beyond MOE, they've layered in other advanced techniques, things like alternating dense and sparse attention patterns, a bit like GPT-3 actually, grouped multi-query attention, which helps with inference speed and memory usage, and rotary positional embedding, ROPE, for handling context effectively. Speaking of context, they support a pretty large window too, up to 128,000 tokens, so it can handle long documents or conversations.
That's a lot of context.
It is. And the training data was massive, mostly English text, focused heavily on STEM subjects, coding, general knowledge. They even open-sourced their tokenizer, called O200 Harmony. And then post-training, there was supervised fine-tuning and a really compute-intensive reinforcement learning stage. Crucially, this was aligned with the OpenAI model spec, specifically teaching it chain-of-thought reasoning and how to use tools effectively.
That makes sense. And I saw something about reasoning efforts. That sounds practical.
Yeah, that's a neat feature for developers. The models support 3 levels: low, medium, and high reasoning effort. It basically lets you dial in the trade-off you want between how fast it responds, the latency, versus how deeply it thinks, the performance. Just a simple setting. Very useful for deployment scenarios.
Okay, let's shift a bit to how these models are actually meant to be used, because this seems like where it gets really interesting for building things, right? They mentioned compatibility with the Responses API and a design focused on agentic workflows. What does that really mean in practice?
Right, agentic workflows basically means the model is designed to act more like an agent. So really good at following complex instructions, using tools like calling out to a web search or running Python code to solve a problem, and doing dynamic reasoning, adapting its approach as it goes.
And this connects to the chain of thought idea you mentioned earlier.
Exactly. And this is where a really critical design choice comes in. They specifically decided not to put direct supervision on the chain of thought, the committee, for alignment.
No alignment supervision on the internal thoughts. Why?
Their reasoning is that keeping the committee sort of raw, unfiltered, is crucial for monitoring, for spotting potential misbehavior or deception, or even attempts at misuse. It gives researchers a clearer window into the model's actual process. But this creates a fascinating paradox. The models are apparently very good at following instructions in their final output, the bit the user sees. But their internal thought process, the committee, might actually show the model disobeying instructions, or even containing stuff that's hallucinated or harmful.
Wow. So it might think things it knows it shouldn't say?
Precisely. The example they gave is striking. Tell the model, never say the word 5. The final answer might be perfectly fine, like about 4.9 or maybe 4.73. It obeys. But if you could look inside, at the coatee, you might see the model explicitly thinking about the word 5, struggling with the constraint before settling on the safe answer. Because of this, the official advice to developers is crystal clear. Do not show the raw coatee directly to end users in your apps. You risk exposing them to potentially harmful content or just information the model was specifically told not to output.
Okay, I get it. So it's this incredibly valuable transparency for researchers studying AI cognition or, misbehavior. But for developers building applications, it means you absolutely need a layer between the model's raw thoughts and what the user sees. Careful handling required. All right, let's talk safety. Always a huge topic with AI, especially powerful open models. It sounds like they put a lot of effort here.
They did, absolutely. It looks like a really comprehensive, multi-layered approach. Started during pre-training. They filtered out harmful data specifically related to CBRN threats, chemical, biological, radiological, nuclear. Then, after the main training and the post-training phase, they used techniques like deliberative alignment and an instruction hierarchy, basically teaching the model to recognize and refuse unsafe prompts and also how to defend against things like prompt injections.
Okay, so proactive filtering and alignment training. What about testing?
That's where it gets quite rigorous. They did proactive risk assessments. They actually fine-tuned versions of the GPS-120B model adversarially, trying to make them malicious, essentially. They trained these versions on specialized biology and cybersecurity data, trying to push them towards dangerous capabilities. But even after this targeted adversarial fine-tuning, these maliciously tuned models reportedly couldn't reach high capability levels according to their internal preparedness framework for assessing dangerous potential.
And they had this checked externally.
Yes. They mentioned having external experts review this whole methodology. And to push safety even further, they've launched a red teaming challenge. Big prize fund, $500,000, inviting the global research community to find novel safety issues. And they've promised to publish a report on the findings and even open source an evaluation data set based on validated vulnerabilities found during the challenge.
That sounds really thorough. Proactive internal testing, external review, community bug bounties. It feels like they're trying to establish a new standard for safety practices with open weight models, tackling those accessibility concerns head on. Speaking of accessibility, how easy is it for someone to actually get their hands on these models and run them?
It seems remarkably accessible. The model 8s themselves, freely downloadable from Hugging Face. That's standard good practice now. And they come natively quantized using a format called MXFP4. That quantization is key to the memory figures we mentioned. GPT-OS 120B running within 80 GLB, and the little GPT-OS 20B needing just 16 GLB.
Makes a huge difference for practical use.
Definitely. They've also open source supporting tools, like their Harmony renderer and reference implementations, to smooth the path for developers. And beyond just providing the weights, they've built a pretty wide network of partners. Think major cloud platforms and deployment tools, Azure, Hugging Face itself, AWS, specialized libraries like VLLM, popular tools like Llama. They're ensuring broad integration. Plus, collaborations with hardware makers, NVIDIA, AMD to get optimized performance on various chips. Microsoft, for instance, is specifically bringing GPU-optimized versions of the 20B model to Windows devices using OpenAI's runtime.
Okay, so the models are out there, they're performant, they've got safety protocols, and they're being made easy to access and run across different platforms. Let's pull back then. Putting all these pieces together, performance, openness, safety, access, what's the big picture? Why does this release really matter in the grand scheme of AI?
Well, I think this release, GPT-OS 120B and 20B, it really marks a significant step up for open-weight models. At this scale, they're delivering real advances in reasoning and safety that, frankly, we haven't quite seen before in the open domain. Now, they're not positioned as replacements for the big, hosted proprietary models necessarily. It's more about complementing them, giving developers, researchers, organizations a much richer toolkit, more choices to balance performance, cost, latency, control.
So expanding the options available.
Exactly. And the core aims seem clear. Accelerate cutting-edge research by providing powerful, open tools, foster more innovation because more people can build on them, and enable safer, more transparent AI development because you can actually look inside, understand the weights, modify them. And perhaps most critically, it lowers the barrier to entry dramatically. For emerging markets, maybe, or sectors like academia or nonprofits that are often resource-constrained, smaller companies too, places that might lack the budget or the technical setup for expensive proprietary APIs. This empowers a much broader base of users globally. They talk about expanding democratic AI rails, and that seems to capture the spirit of it.
Right, so it feels like it's less about just releasing new tools and more about genuinely empowering a wider range of people and organizations, empowering everyone, really from the solo dev tinkering in their basement to large research labs to build, to innovate, create new things with AI, and importantly, doing it on their own terms, potentially even on their own hardware. That feels like the core message. So that wraps up our deep dive into GPT-OS 120B and GPT-OS 20B, clearly very powerful, impressively accessible, designed with safety as a priority, and highly customizable open-weight models that are definitely pushing the boundaries.
Yeah, and maybe a final thought for you, the listener, to chew on. Given this level of performance coming from open-weight models and all these efforts around safety and accessibility, how might this start to shift things? Could we see a move away from near total reliance on closed proprietary systems towards something more, well, democratized, a more collaborative future for AI innovation? What kinds of new possibilities does this open up for you and whatever you're working on or interested in? Something to think about.